Shall we start, ma'am?
Yes, sir. Once again, board adjust பண்ணிக்கலாம். Voice okay, yes, sir?
Okay, ma'am. You
Okay,
can
sir.
start, ma'am.
Good evening, children. In ninth standard science, today's topic is states of matter. Okay. States of matter. There are three kinds of states. Already we know about the basic concept of this concept. Yes, in Earth, there are different kinds of materials we can observe. Okay, so in our surroundings, we can see different varieties of things with different shapes and sizes also. So these types of materials are called as matter. Okay, what is matter? Matter is nothing but some matter is the anything that take up the space and can be that weight also. So these kind of materials are called as that matter. Anything that has mass and occupies space is called matter. Okay, what is matter means anything that has mass and occupies space, and space is called the matter. Okay, so a matter, what is uh, states means nothing but the matter is anything that take up the space and can be that weight. Okay, yeah, these are called all the states. So anything that has mass and occupies the space. So matter means matter contains a lot of tiny particles. Okay, a matter is made up of tiny materials. Okay, tiny particles. These tiny particle is called as atom. Okay, atom means nothing but matter is made up of tiny particles. So that is called as atom. Okay, so each and every material is made up of atoms and molecules. Okay, we are used to different kinds of materials, glass materials, rubber material, wooden material. These materials are made up of atom and molecules. Okay, this is the basic concept. Okay, so there are three kinds of states. So the title of that session is states of matter. Okay, so there are three kinds of states. What are they? Solid, liquid, and gas. Solid, liquid, and gas. These are all called as the types of states. So there are three types of states. What are they? Solid and liquid and gas. Okay, so these are all the three kinds of states. Okay, there are three kinds of states, that is solid, liquid, and gas. So we can segregate the states into three types. Okay, three types of states, that is solid, liquid, and gas. Now we are going to learn the concept, how they made up of. Okay, and then how that properties of that three states also. Okay, first you are going to see the solid materials. What are the solid materials? Yes, we can use this. What is this? This is book. Okay, and what is this? This is pen. Okay, and then next one is, this is also a pen. So these are all made up of different materials, plastic and then paper, like that. but basically it is called as solid material. Okay, yeah. Solid material means what are the concept of that solid material. Solid material means they are having the different proper shapes. Okay, yeah. How we can define that? Solid means the solid have definite shapes. Definite shapes. Yes, book have definite shape, and then pencil have definite shape, eraser and bench, chair, almirah, TV, mobile. These are all the example of solid materials. Okay, yeah. Pen, pencil, bench, book. Okay, yeah. So these materials are have definite shapes and then definite volume also. They are definite volume and then definite mass. Okay, so these kind of material is called as solid. Okay, solid materials are solid states. Okay, solid states means book, bench, glass material, rubber material. These are all that group of solid states materials. Okay, so they are having the definite shape, volume, mass, and then clear boundaries also. Okay, yeah, they are having proper boundaries. Okay, solid materials have the proper boundary. Book have the proper boundary, and then pencil, pen, boxes, each and every solid state material have the clear boundaries, definite shapes and definite volume and definite mass also. Okay, yeah. So this is the concept of the solid state. And then next one is next one more important property of the solid is less compressibility. Okay, yeah. Compressibility means how just we want to break the material means we don't want to break. Okay, so we can't break the material easily. So less compressible. Okay, yeah. Less negligible. So solid state materials are less compressible. Okay, less compressible. So in solid materials, molecules are closely packed. These materials are closely packed. So atoms and molecules are closely packed in solid state materials. Okay, yeah. First thing is definite volume, definite mass, and then definite shape and less compressibility and closely packed materials. So these are all the properties of solid state. Okay, yeah. So closely or tightly packed. So we need some energy to break the material. I want to break some wooden material means we need some energy to break. Why? Because the atoms and molecules are closely packed in solid state materials. That's why we need more energy to break the materials. Okay, yeah. Is that clear, Pa? There are three kinds of states. First one is solid state. Solid states materials have definite shape, definite volume, definite mass also. Okay. And then less compressibility. We want just we need energy to break the materials. Why? Because the atoms and molecules are tightly packed in that area. Okay. So next we are going to learn the liquid states. Okay. So cup of water and one more water bottle container and then one more tumbler of juice. What is this? These are all the example for liquid states. Okay, water, juice, coffee, oil. These are all the examples for the liquid state materials. Day-to-day life, we are using these kinds of material, is it or not? So these are all called as liquids. Okay. So what are the property? First thing, the liquid state particles are loosely packed. Loosely packed. That is, atoms and molecules are loosely packed in this liquid states. Okay, yeah. So they move freely. They move freely in that area. Okay. They don't have the definite shape. Okay. They don't have, solid materials have the definite shapes, but no definite shapes in liquid materials. Okay, yeah. They don't have the fixed shape or definite shape, but they have fixed volume. The volume is fixed. Just we saw the tumbler of juice and water, bottle of water, a cup of tea, like that. But they have fixed volume. They don't have definite shape. The molecules are freely moved, loosely packed. So these are all the properties of liquids. Milk, juice, oil. These are all the examples of liquid materials, liquid state materials. Okay. So we can observe the liquids have no definite shape but have a fixed volume. They take the shape of the container because this is one type of container and this is one type of container. So they take up the shape of the container. They don't have the fixed shape. They don't have the definite shapes. This is the main property of liquid state. Understand? So these are all the qualities, properties of that liquid state. The atoms and molecules are loosely packed in that places. They move freely. They don't have no definite shape, but fixed value. So these are all the liquid state materials properties. Okay, so next one is gas. This is also the last state. There are three states. One is liquid, solid, and then third one is gaseous. Okay, this is also the important states. Gas. Okay. What are the main qualities of gas? So what are the examples? Balloon, tire, and cylinder. These are all the examples of gas materials. Balloon, tire, and cylinder. Okay. So in the gaseous state, the particles are freely packed, not loosely packed. They are freely packed. Atoms and molecules are freely packed. Atoms are freely packed in gas state. Okay. In gaseous state, the atoms are freely packed. The movement of the particles are also high. Movement of the particles. Also high. Okay. So this is also the second superior quality of the gaseous state. Then the third property is highly compressible. Okay, yeah. The third property is highly compressible. Yes. Yes, this is the balloon. Okay, yeah. Yes, I compress the balloon easily. I can't compress book, pen, pencil like that. When I compress the balloon, easily burst out. Okay, the gases come out that area. So, highly compressible state is gaseous state. In gaseous state, the atoms are freely packed. Movement of the particles also high and then highly compressible. Okay, compared to solid and liquid materials, this is highly compressible. Okay, so these are all the qualities of the solid and liquid materials. Okay. So what are they? Metal material, glass material, plastic, fabric, and then concrete, wooden material, ceramic material, rubber materials. Though these are all the examples for solid state materials. Okay, made up of metal, glass, plastics, whatever it may be. These are all have definite shape, definite volume, definite mass also. We can't break these material easily. Okay, so very less compressible material, one or two material, fabric, sponge, like that only compressible. These are all not compressible. Tire and then ceramic materials are not compressible. So these are all that solid materials examples. Okay. Just a minute. This is the example of liquid materials. Okay, so liquid materials, different kinds of shapes. This is called beaker. This is called conical flask. This is called a round bottom flask. Different shapes of conical, different sizes of conical flasks. So they have that. They don't have the definite shapes. Okay, so this is the examples for the liquid state materials. Okay, they take up of the vessels. Now I'm going to share one simulation for the states of matter. So having that one container, and then there are 4 properties: neon, argon, oxygen, and water. Okay, neon, argon, oxygen, and water are non-metal categories. Argon, neon, and water, they are the non-metal categories. Okay, so in this simulation, we are going to see that different states of matter with its properties also. Okay, here we are having the different kinds of properties. So, neon, argon, oxygen, and then water are the non-metal categories. So first I am choosing the neon in solid state. Having the thermometer here, also the temperature also here. Notice, first one in solid state, neon temperature is 14 Kelvin. Going to change the neon liquid. So the temperature is increased 14 to 28 Kelvin. And then gaseous state, the temperature is 56 Kelvin. Okay. So see this packing atoms and molecules, how they are packed in solid state. The atoms and the molecules are closely packed. Visually, we observe the arrangement of the molecules in solid state. They are closely packed. In liquid state, loosely packed. Okay, they are packing in loose. And then gaseous state, freely moved. Okay, they are packed in freely. Okay, so solid state, they are packed. The molecules are closely arranged. In liquid state, the molecules are freely and then gaseous states they are, and then loose. Okay, so these are all the kinds, and as well as the temperature also vary. In argon, in solid state, it is 43 Kelvin. In liquid state, it is an 86 Kelvin. And then gas, it is 189 Kelvin. Okay, yeah. When we want to change the state, means the temperature also increased. Okay. And next one, oxygen, O2. So solid. Solid means it is closely packed. The temperature is 27 Kelvin. And then next state, liquid, 57 Kelvin. And gas, 113 Kelvin. Okay, yeah. So this is the nature of oxygen. Next one is water. So water state, solid state, that is cubical state, 146 Kelvin. Liquid state in water, so 286 Kelvin. Gas, 430 Kelvin is converted into gas. So these are all the main two properties, that is how they are arranged in three states, how the temperature also vary from one to another. So these two properties we can observe from this first part of simulation. So there are two parts in this simulation. One is when we can observe the states of these three matters and how they differ the temperatures from one to another. Now I'm going to the second. Okay, so what are the special components are having? One is pump and another one is pressure indicator, and then temperature also noticed in this place. Okay, so when I want to increase the temperature also, first I want to increase the number of molecules. So I increase the molecule numbers from the help of this pump. When I press the pump, the molecules, number of molecules are increased in this area. Okay, yeah. So, yes, is that clear? Next, I'm choosing the neon. Just I'm going to want to heat this. So, these materials are heated. Okay, just I'm going to boil this area. The temperature is increased as well as the pressure also vary. So 67, 69, 83. Okay, yeah. So 123 Kelvin. So the temperature is increased. When I want to heat this vessel, the temperature also increased, the pressure also increased. Now I'm going to press the lid. Okay, yeah. The top of the lid, I want to press it. So immediately that lid was opened. Why? Because the temperature also increased and the pressure also increased. So the lid is come out from that place. See, next one. Because the Gay-Lussac principle is the example of this. In practical life, the pressure cooker, the temperature also increased, and then pressure also increased, means the cooker lid is easily come out from that area. Okay, yeah. In this manner, this place, sure, argon. Okay, so just I increase the temperature. Notice the temperature and the pressure also differ from one to another. This neon, argon, oxygen and water temperature is differ. Okay, when I heat this area, the temperature is also increased and then pressure also increased. Okay, now I'm going to press the lid. So in this area, the molecules are so highly compressible. Okay, yeah. So, and then just I want to press here. The temperature is 167. In that temperature only argon lid is come out this area. So the pressure also increased. And then third one is oxygen. In oxygen particles, notice the temperature, it is differ from all. I want to heat that oxygen, temperature increased as well as the pressure is slowly increased. Notice the pressure part. See here, the molecules are moved here and there. Okay. They bombard the wall also. The temperature is increased slowly. 226, 300 like that. The pressure also very, very slowly the pressure is increased. Little by little only the temperature level is changed in water molecules. Sorry, oxygen. 423, 444. Just notice the temperature and the pressure also. The thermometer level also increased. The red part of that area is moved upward. So the temperature is increased. The red part also increased. Just I want to press the lid, top of that place. Little by little, I want to press it. In which temperature the lid is come out that area, please note down. The pressure is also vary. Atmospheric pressure. So the high temperature and the pressure, the oxygen particles are come out that place area. Okay. Next, I'm going to choose water. So water particles are, and we say they are closely packed. I want to increase the temperature. Want to heat this area. The temperature is increased. The pressure is also slowly in here. Here the particles are moving slowly. When the temperature is high, then freely as well as the fast movement also. Notice the temperature level and the pressure level. So see here 190, 194. The boiling point of the water is 100 degrees Celsius. Is it or not? So the molecules are randomly moved in this area. Just I'm going to press the lid. So this, see here. So the temperature level also low as well as the pressure in water particles. The temperature is not more than 500. Within that temperature, the lid is come out that area. So we can observe the 3 states of matter. Okay. Just when I heat this state means this is in solid state. So the particles are moved. And then see here, liquid state, I want to heat that means how they are moved. Easily come out from that area. And then gas. So how they are moved. This is called as freely packed. Okay, the molecules are freely packed. So we can clearly observe the states of matter. And then what are the main properties? And then they are how they can move and then boiling point. Just I observe, we can observe these simulation with the help of that. How they are moved, how they are packed, How they are changed depends upon the pressure and the temperature, how the states are changed. Okay, students, is it clear? Is there any doubt in this place? Okay, next one, another one concept is just a minute. So diffusion, what is called as diffusion? Diffusion is nothing but yeah, I'm going to share one more simulation. From this simulation, how the particles, the solid particles and the liquid particles of the properties, what are the properties? Classification, flotation, hardness, solubility, and the transparency. Okay, yeah, these are all the classification of materials. I am having different kinds of materials: wax, glass piece, oil paper, sugar, leaf, coal, wood, coin, sponge, like that. With the help of these materials, I am going to show the kinds of the characteristics. First, I am choosing flotation. So, this is wax. Thus, I'm going to, yeah, how does the sinking or floating? The wax bar is sinking or floating. Which one is right? It is floating or sinking? Yes, this is floating. Okay, yeah, because this is weightless material. Next, I am going to taking glass piece. Wax also the solid material. Glass piece also that solid material. But that characteristics are differ. It is sinking or floating? Yes, it is sinking. And then I am choosing leaf. Yeah, just I put the leaf into the beaker. It is floating or sinking? Yes, this is floating. So this is weightless material. Next one is coal. Coal is weightless material or weighted material? Yes, it is weightless material. So it is floating on the water. Wooden material. Wooden material also weightless property. So it is also floating. Coin, next one. So I am selecting that coin. It is floating or sinking? Yes, sink into the water. Okay. So these are all the characteristics. These are all the solid particles. Hardness of the particles, just we can identify from this help of this part. Next one. Next one is hardness. Just we want to clear the hardness of the material. This is wax bar. This is hard or soft? Yes, definitely it is the soft materials. Okay, so selected the soft. Glass piece compared to wax bar, glass piece hardness is heavier. Okay, so this is hard material. A leaf. Leaf is a soft material. Is it or not? So that is, so I am choosing the soft part. Okay, and then coal. Coal is the soft or hard material. It is the soft material I'm choosing. Wow, why it is in red color? Yes, I am choosing the wrong answer. But it is a hard material. Coal is a hard material. And then wooden material. Wooden material is hard or soft? It is the hard material. So, iron coin, it is also the hard. Okay, so I select the soft material means it is in red color. Wrong answer. So I choose the hard. Iron is that hard materials means it will come that green color. Okay, yeah. So these are all in this simulation. we can identify the hardness of the materials also. Okay, yeah. So next one is solubility. Solubility means how we can identify the solubilities. One second. Solubility means liquid particles are dissolved in water. Okay, yeah. What are the particles? What are the wax, glass piece, oil paper, sugar, leaf, coal, and then wooden bar and coin. First, I'm going to choose the sugar. Thus, I'm taking the little bit of sugar, the help of the spatula, and put into the water. Just I taking the stirrer and the water is stirred. Okay. Yes, the sugar particle is dissolved. So it is dissolved in water. Sugar cubes are dissolved into water. So this property is called as solubility. The liquid material is dissolved. Okay, yeah, the solid material is dissolved in the liquid material. This is called as solubility. And then next one, I am going to choose the leaf. The leaf, I am just putting to the leaf the beaker. Take the stirrer and just stir that material. The leaf is not soluble. So this is called as insoluble. Insolubility. The leaf is not soluble in this water. So this is called insoluble material. I'm taking the coal, put into the beaker, and then once again want to stir this solution. Yes, the coal is also not dissolved. Okay, so this is insoluble material. So glass piece, and then stir this. Yes, this is also insoluble material. So in all these material, which one is the soluble? Yes, sugar one is the soluble. Remaining all are the insoluble matter. Okay, yeah. So from this simulation, we can observe what are the solid state and then liquid state materials, how they are soluble and insoluble, and the hardness of the material and floating sinking. That matter, that kind of property also we can observe this. Okay, yeah. So next one is yeah, just we can from the simulation solid materials and then liquid material and gas, these three states of matter also we can notice in this simulation. This plate, yeah, we are having four kind of property. One is magnet, and then water container and glass beaker, stirrer, and different kinds of materials are mixed in this plate. Iron, sand, and common salt mixture is in this plate. Okay, now I am going to choose the magnet. Magnet is attracted the iron particles. This is the basic concept, is it? So the iron particles are attracted to the magnet. So the iron particles are removed from this plate. What are the materials are remaining in this area? Sand and common salt. Okay, yeah. So now I'm going to choose the taking the plate and put into the beaker and add some water to the beaker. Add some water into the beaker, and then I want to stir the solution. So just I'm stirring the solution. Notice the beaker. The sand particles are settled down the bottom of the beaker. First, in this plate, there are three particles are mixed in that area. One is iron, sand, and salt mixture. Iron particles are easily separated with the help of the magnet. And then just I put the remaining part. What are they? Sand and salt. These two particles, just I put into the beaker and add some water. So the magnet separate filings from the mixture of salt, iron, and sand. Okay. Next one. What is this? This is called as tripod stand, beaker, and then sand mixture, water, funnel, and then paper. Okay, yeah. So just I'm going to taking the funnel, sorry, just the beaker and keep it on the area. Okay, sorry, funnel, and then fix the paper. Yeah, it is in cone shape. I'm going to pour the water into the paper. Okay, yeah, filter paper. This is called as filter paper. The waste particles, that is, the sand particles are filtered in this area. So, first I want to separate the magnetic particles, that is iron particles. Solid particles are separated from with the help of the magnet, and then next one, sand particles are separated with the help of the water. Water is in liquid state. Okay, so the sand is also separated, the salt only in that container. Okay, yeah, this is salt water. Next, I am going to separate the salt from this area. So from among three materials, sand and magnetic iron filings and then salt, two particles are separated, iron and sand. Only salt particles only mixed in that area. Just so I want to separate the salt. Just want to heat the beaker. So the burner is blue. So see this beaker, water is evaporated. How they evaporated? Yes, water is the universal solvent. The water is only in the three states: solid state, liquid state, and then gaseous state. Solid state in cube, ice cube, liquid in water state. Water vapor is the gaseous state of water. Yes, the water is evaporated from this area. The salt particles are settled the outside, the inside of the beaker. So clearly observed in this plate, white dotted part is salt material. So solid, liquid, and gas, these three states are observed from this simulation, sit or not. So the salt is separated, the process of boiling. When we want to boil the water is evaporated. That is water vapor, gaseous state. So from these three simulations, we can observe that how the solid state and then liquid state and then gaseous states are separated, how we can identify, how we can separated, and then that boiling point at the temperature and then pressure level also vary from one element to another element also, we notice that. Okay, yeah. So next, yes, we observed one concept, that is diffusion. What is diffusion? Diffusion means just the sugar and salt cubes are dissolved in water. How they are dissolved? Because they can easily dissolve that kind of material. So it is dissolved in that place. Okay, yeah. So that one more properties of that liquids. So among solid, liquid, gases can diffuse into the liquids only. So solid and then liquid and gas. Which one is diffused means? So the concept is diffusion. Concept is diffusion. Okay. What is diffusion? Diffusion, nothing but the rate of the diffusion of liquid is higher than that the solids. Solids and liquids and gases can diffuse into liquids. Okay. How it is possible? Yes, solid materials. Solid material means ice cubes and normal cubical structure of sugar, salt. So these are all diffused into the liquid easily. When we want to prepare the lemon juice, means we need, what are they? Lemon juice and then sugar and water. Yes, the lemon juice and then sugar or salt is diffused into that water. So the solid material is diffused into the liquids. Liquid and liquids easily immersed. So just I want to mix the cold water and the hot water. The liquids and liquid to liquid easily diffused, and then gases. So how the gas particles are diffused, it means carbon dioxide and then gas. The gases from the atmosphere diffuse and dissolved in water. Is it or not? The gases of are oxygen and carbon dioxide. These two gases are essential for our survival, because when we want to survive in this earth, we need oxygen for human, carbon dioxide for plants. So plants, animals, and then human beings. Okay, yeah. So these three categories need to survive in this earth, means we need these two gases, oxygen and carbon dioxide. Okay, yeah. How the aquatic animals are breathe, ma? Plants and animals and human beings are breathing easily with the help of atmospheric gases, that oxygen and carbon dioxide. Yes, we receive the oxygen from our atmospheric area. How the aquatic animals are received? Yes, the oxygen is dissolved in that liquid in water. Okay, yeah. So these two gases are essential for the aquatic animals and water. So these two gases are dissolved in the water molecule. Water molecules, formula of water molecule is H2O. 2 part of hydrogen and then 1 part of oxygen. So this is that molecular formula of water. So oxygen is diffused in this water. So the aquatic animals are breathe with the help of that water. Okay, yeah. How they breathe means the aquatic animals are receive the oxygen from the water. Okay, so all living organism to breathe for survival. So this is the one more concept. And then in gaseous state, gas means there are different kinds of gases. What are the gases? We do know just oxygen, neon, like that also. So in gaseous states, in olden days, we are use different kinds of materials like preparation of cooking. Okay, what are the materials we use? Wooden material, kerosene stove, like that. Okay, nowadays we are using what is the main one? LPG, liquid petroleum gas, and then CNG. So this is the two important gases, LPG and then CNG. Okay. LPG means what? Liquefied petroleum gas. Liquefied petroleum gas is called LPG. Compressed natural gas. Compressed natural gas is CNG. Okay, yeah. What are the uses of liquefied petroleum gas? Liquid petroleum gas for cooking purpose. Without LPG, we can't prepare the food nowadays. Sit. Yes, our parents, our mother is prepared within an hour for our lunch and then breakfast also. How it is possible? with the help of LPG. So the LPG means liquefied petroleum gas. So it is used for cooking purpose. Okay. So cooking purpose we use LPG gas, and then CNG used for cars and then automobiles, mainly cars and then buses. Okay. CNG. So the compressed natural gases is used in cars and buses and used for the power generation purpose also. Power is generated from this place, compressed gas. With the help of that CNG, we can prepare the power. Okay. So that LPG and the CNG. So LPG means liquid petroleum gas. This is used for our main purpose is cooking, as well as also it is used for in automobiles also. And CNG means compressed natural gas. It is used for cars and buses, and then it is used to prepare the power generations also. Okay. Just I am going to recall what are the details we learned in this sessions. Just what are the three states? Solid state, liquid state, and then gaseous state. So before that, I want to clarify some. Students, is there any doubts or just you can't understand the topic means you please ask me. Once again, I'm going to explain the concept and with the help of that simulations also. So please, is there any doubts? Is there any doubts mean? Just you type in chat box. Definitely, I will answer the questions. Okay. First concept is we learned matter. What is matter? Matter means all the materials are made up of atoms and molecules. That material is called as matter. Okay. What is matter means? Just we can see different materials in this area. Different kinds of materials, wooden material, rubber material, metal material, like that materials. These materials are made up of tiny particles that is called as atoms and molecules. So the three states means solid, liquid, and gas. Okay. So in these three states, solid means solid materials, the tiny particles, that is atoms and molecules are tightly arranged, closely arranged. So they have definite shapes and volume and mass also. Okay. And then one more important property, they have the clear boundaries also, and then less compressible, very less compressible materials are solid state. In liquid state materials, they are loosely packed. The atoms and molecules are loosely packed and they don't have the definite shapes. They take up the shape of the container only. Okay. Liquids flow and change their shapes also. Just I pour the water from the tumbler means they flow from that area. Okay. Yeah. So they don't have the definite shapes. So the liquid particles are loosely packed. The state of particle is moving of the particles also greater. Okay. And then gaseous states, the atoms and molecules are freely packed. So they move here and there. I think visually we observe with the help of the simulation, these states of matter, how the molecules are one place to another. When I change the states in solid states, they can't move. Liquid state, little bit moving, and then gaseous state, they are moving randomly, okay, in fast manner also. This is the main property, okay. In gas means they don't have the definite shapes also. They are highly compressible also, okay. Yeah. And then next one is just we learned the one more concept, diffusion. Diffusion means solid liquid gases can diffuse into liquid materials. The rate of the diffusion, liquid is higher than the solids. Okay, so the liquid state particles move freely. This is the main concept of that diffusion. Okay. because they have the more space in that area, so they move freely. Okay, and then gases of the atmosphere, diffusion, and the oxygen, carbon dioxide gases are diffused into water, so that the aquatic animals also easily breathe in that area. Okay, plants, animals, and human beings are breathe with the help of the atmospheric gases, but aquatic animals are breathe with the help of the oxygen, and carbon dioxide are diffused into the water, so they can absorb the oxygen from that area, they can breathe easily. So just these are all the concepts we learned in this session. We learned the solid, liquid, gases properties, and then next one is three kinds of simulations also I show. So with that simulation, we can get more idea about the three states. Students, is there any doubt, means please ask me. Is that clear? The concept of that solid state and then liquid state and then gaseous states are clear. How they can arrange, how they can raise the temperature, and when we want to increase the temperature and pressure, how they are moved. Okay, so there are different four kinds of properties we used: organ, neon, and oxygen, and water. With the help of the simulations, we learned the properties of that. There are two properties. One is boiling. So the how they when we want to boiled means the materials are moved here and that. That concept also we understood in that place. So there is no doubt, means just you go and revise the topic thoroughly. So when we want to understand, when we want to learn the topics, means definitely just your basic concept of that study is each and every day just want to revise that portions. What are the topics we learned and that day just you revise. When we revise the topics, means definitely it will be registered in our mind. So that is the main concept. So please go and revise the topics. Just you go through the topics. I think you understand the topics, means you go and take your book and what are the topics I taught. Just you sort out the topic and then just you revise that. Is there any doubts? You please ask me the next session also. Definitely, I will explain the topics once again. Okay, yeah. Okay, thank you, students. Jai Vidya Shakti, Jai Bharat, Jai Hind.
Thank you, ma'am.